Okay, let's see the Gauss backward interpolating formula. If I'm asked to apply Gauss backward interpolating formula, the formula goes like y naught plus p into delta y minus 1, one step, just a second, one step backward first. Backward is denoted by plus. Okay, delta square y minus 1 plus one step backward first, then one step forward. I'm sorry. One step forward is denoted by the negative sign. Okay. Delta Q y minus 2. Okay. Plus, I'll just try it one more and then stop. One step backward, one step forward, and one step backward. Four terms are there. So 4 factorial, and the fourth order difference is also there. Y minus 2 and so on. The formula goes like this. Okay. Backward interpolating formula. How do I solve a problem using backward interpolating formula? Let's see. Okay. Interpolate using Gauss backward interpolation formula for the following data at x is equal to 1974. Okay. Of course, population has been given and the years are being given, population has been given. These are all in millions, guys. Okay. First, for anything, we'll be constructing the table. For any interpolating problem, we'll be constructing the table. Okay, let's construct the table. For Gauss, you ought to take care of where the data starts, what's x naught and all that, and then proceed with. Okay, right. Now, 1939, backward formula has been asked, 1949, 1959, 1969, 1979, 1989 are all being given. At 1974. So where do I start my interpolation with? Backward formula he has asked. Okay. So I'll be taking this value. I should be taking this value, of course. Just a second. The problem is like 1964. It's been asked. So this would be my 69 would be my x naught. This would be my x1, x minus 1, minus 2, x minus 3. And this would be x1, this would be x2. Of course, accordingly, my y value is also coming into picture. This is 12, 15, 20, 27, 39, 52. This is y minus 3, y minus 2, y minus 1, y naught, y1, and y2. Okay. Now coming to the differences, I'll be finding the differences. I'll be writing those differences exactly at the center, not to lose track. This would be 3, 5, 7, 12, and 13. Next differences would be 2, 2, 5, and 1, 0, 3, and minus 4. Third differences. Fourth differences would be 3, minus 7. And fifth differences would be minus 10. Okay, so how do I start? I'll just show, of course, the formula is anyways there. If this is my y naught, okay, backward formula I am taking. Okay, so from here, I will take a step backward. Let me use a different color so that it's obvious too. I'll take a step backward first. This is forward. Next backward, forward, and backward. Okay, that's how I'll take the values. I can just write what's the value of P. P is x minus x naught by h. What's X been given to me as? What I have? 1964. 1964 minus X naught, I have chosen it to be 1969. H I can clearly see X naught, X1 is equal to X naught plus H. So how am I getting? X naught plus 10 is giving me X1. So it is H is 10. So this value, let me calculate and write H value so that remaining things just follow. Okay. This is nothing but minus 5 by 10, which is minus 1 by 2, which is equal to minus 0.5. So accordingly, the formula goes y at 1964, this is equal to y naught plus p into delta y minus 1, I'll be calling this to be, plus p into p plus 1, one step backward, delta squared y minus 2, plus p into one step backward, one step forward, delta cube y minus 2. And it goes on and on. How many differences are there? Just see 1, 2, 3, 4 and 5 differences are there. Till there you will write the formula. The answer, I just have the answer. I will just share the answer with you. The answer turns out to be something around at 1964. It turns out to be around 30. It turns out to be around, just see here. Yeah, I'm sorry. 23.4. Around this, the value turns out to be. This is how we will do backward interpolation. It's all about writing the formula properly and then writing the differences exactly at the center so that I'm not in a wrong track, and putting those differences in the formula and getting the values using a calculator. Thank you.